Okay, now next is the torque equation of the motor. So torque is to be calculated, and there is a motor in which force F is generated due to the presence of electricity or applied electricity, and the radius of the armature is R. Now torque is known as force into perpendicular distance, so it is shown here. Okay, so what is the work done by this force in one revolution? What is work done? Force into distance. Okay, and in one revolution the rotor will have the one circle. What is this? 2 pi r. Okay, and this 2 pi r is known as what? What is this 2 pi r? Perimeter. Okay, so this is the perimeter of the distance traveled in one circle. Okay, so now what is the power developed? Mechanical power. What do you mean by mechanical power? It is power is equal to force into velocity. So velocity n is given in rps as shown in the diagram, revolutions per second. Okay, so if n is the number of revolutions per second, then the total distance which will be covered in one rotation, it is 2 pi r. So in n rotation it will be 2 pi r into n. This force into velocity is now segregated as F into R into 2 pi n. Okay, F into R is the torque and 2 pi n is the angular velocity. So power is equal to tau omega. Okay, that is known to us. Okay, so I have not given the theory part of this description. You can interpret and write in your own words or refer any book or literature or net. Okay, now the armature torque is this power is equal to tau omega. It is again now converted into tau a because we are dealing with the armature torque. Now if there is lossless system, then the electrical power will be converted into mechanical power. So tau omega or this tau into 2 pi n is equal to EBIA, which is volt current. This is power. So now back EMF is substituted as phi Z NP upon A. Okay, why upon A? Because in the EMF equation we have written upon 60A when n is given in RPM. But if it is given in RPS, then it becomes A. Okay, so this EMF is multiplied by current IA, and this whatever terms are cancelled out, it is good enough. The resultant will be 0.159 phi Z IA P upon a Newton meter. So this is the torque equation of the motor. So next part is the type of motors. So this is again construction wise, it is similar to the DC shunt motor, series motor and compound motor. Only difference, because the construction wise they are the same. Okay, what is the difference? Difference is just that in the motor current is supplied and in the generator current is taken out. Okay, so the direction of the current reverses, rest everything remains same, whether it is field of excitation, types. Okay, and other thing which is different is the applications which we will taken, which we already explained, but here again I have listed for your convenience. Okay, so these are the application of the DC motors: DC shunt motor, compound motor, permanent magnet motor. Nothing is to be explained here, it is only to be remembered. Okay, now the topic, last topic of this DC machines is the construction of DC machine. Okay, so what do we understand by the construction of DC machine? Is the explanation of different parts. Okay, so we will take and that parts one by one. The model has already been shown to you, explained to you. Now I will explain its parts. Okay, so as far as parts goes, first is the same, the external portion of the DC machine is called yoke. Okay, so it is made up of cast iron and cast steel. Okay, and what are the properties which are essential in this case? Let me explain you. Okay, so say this is our DC machine. This is our shaft. This is our armature. Okay, so this external portion is called yoke. So it is made up of cast iron and cast steel. So cast iron and cast steel are also having it, two properties are associated with these yoke based on the purpose it has to serve. First purpose is the mechanical strength. Okay, it should be iron is very strong mechanical properties, it is having very strong mechanical, so it is not, it does not go to the rusting easily, mechanical damage is not possible easily, it is not prone to any termite attack. Okay, so external damage can be avoided. Second thing is the, since it is the cast iron based ferrous based yoke, so it is also having the good magnetic properties. So what is the role of the good magnetic properties here is that uh, what is below the yoke is the magnetic field. Okay, say our north pole is here and south pole is here. Okay, it is shown outwards but it is within the yoke. Okay, so this is the pole arc. Okay, let us suppose that it is the two pole machine. Okay, so this is the pole arc. So the flux lines are to be passed from north pole to south pole. Okay, good enough. But since the pole arc is not covering the whole distance in a circular manner, so some of the flux might leak from the desired path into external circuit. Okay, but since this yoke external portion is also having the magnetic properties, so they will redirect these flux which is coming from say north pole, it will redirect it to the south pole. Okay, so this purpose is also solved. Okay, so next is our this magnetic field. These magnetic fields are of three types as we have explained in the classification of the DC generator, that it can be permanent type, it can be self-excited DC generated, or it can be separately excited. And the permanent magnet types are the best ones because it is having the strong magnetic field, then it is the self-excited, then lastly it is the separately excited. Okay, so what is these magnets are having the field coils. That was also explained during the construction, during the working part. This is having the field coils. Okay, so what is the purpose of this field coils? Suppose this is our three-phase supply. It is connected to any rectifier. Rectifier will convert into DC, and this DC current is passed to these field coils. Okay, so it will energizes or electromagnetize the magnetic field. Then the more and more flux lines will pass through north pole to south pole. Okay, and if it is the self excited, then this armature is having the armature slots, which I have shown you in the model of the transformer, and these armature slots are having the armature winding. Okay, so these windings are of two types: wave type and lap type, which I have explained you. And they are generally made up of copper. Okay, so and these flux cutting is there, EMF is there, and sinusoidal flux is produced, and sinusoidal EMF is produced. That sinusoidal EMF is converted into rectified EMF, and it is passed on to the load circuit in a rectified manner with the help of this mechanical rectifier called commutator. It is having the copper segments. Okay, so rectified armature winding is connected to the commutator. Now the rectified current is passed on from the commutator to the load circuit via the brushes. Okay, suppose this is the rotor. Now this is the commutator, which I have shown you again, and this is the brushes. So these are the same brushes which we signify in the DC machine, DC motor or generator, both. Okay, what is the general diagram of the DC machine? We just draw the armature, and these two toppings are there. Okay, so these toppings are nothing but the brushes. Okay, so these brushes can be of copper or carbon. Okay, so copper brushes are more superior because the drop is less in case of these copper brushes. But if these brushes are made up of carbon, the drop is more. That is the disadvantage. But the advantage is that these carbon brushes during the armature reaction and the commutation produces the spark and the carbon black, which helps or which acts as a self lubricating device. Okay, so it is self lubricating, so it is helpful. Okay, so now this brushes is also having the brush assembly, which is also having the brush holders. Okay, and this commutator, shaft, armature are all centrally aligned. Okay, similarly this magnetic field, it is having the former in which the slots are there, and in these slots the field coils are placed, and this pole arc is separately connected to it so as to give the desired path to the flux. Okay, what else is connected centrally is the fan system. So fan system is also here. A fan is connected here in the shaft. Shaft is made up of mild steel. Okay, and it is of two types, male type and female type, so that the whenever it is used in the mg set, it can be mechanically coupled. Okay, so this what fan is also centrally connected to mild steel. So whenever the machine is rotating or it is in the load, so I square r heating will be there and I square rt heating will be there. So the fan will serve the purpose of cooling. This is all about the construction of the DC machine.